So welcome back from spring break college algebra. Today we're going to start is the last piece of graphing sine and cosine functions, and we're going to look at phase shifts. Phase shifts are horizontal and vertical shifts in your graphs. We've already looked at changing periods and amplitude changes and reflections when you have a negative in front of the sine or cosine. And now what we're going to do is we're going to show you how to change the graph either vertically or horizontally with a phase shift. Okay? So, there are 4 concrete steps in order to do these problems as they become more complicated. So let me write these down at the top. The first one, you're going to, step number 1, you're going to find the period and the intervals. 2, you're going to use the horizontal shifts. If there is one. If there's not, you can skip that step. 3, you're going to find the first point. And then 4, use the amplitude to graph. So if you can do those 4 steps, all these problems you should have no problems with. Okay, so let's look at what this is. Now, there is one thing that regular college algebra does not do that college algebra honors would do, and that is to have a phase shift, a horizontal phase shift with a period change. That causes a lot of problems, so we are going to not address it in this particular class because we just don't want to. If you're in college algebra honors, you would be able to do that. Here, we're just going to show you it without those 2 things combined. All right. So, if we have this, we have step 1. All right. Because we got to find the period and its intervals. Because there's nothing that's happening to the x, either multiplying or dividing it, then the period stays as 2 pi. So I'm going to write down 2 pi. I'm going to write it in the bottom here. So we have 2 pi as our period. I'm going to find the intervals. So half of 2 pi is pi. All right. Half of pi is pi over 2. And 3 times pi over 2 is 3 pi over 2. Okay, so we did step number 1, find the period and its intervals. Step number 3 is the phase shift, or the horizontal shift. Okay, so if you have something on the inside of the function, in this parentheses, this is a horizontal shift. It was on the outside, like in question number 2, this plus 2. This is a vertical shift, okay? Since it's on the inside, we're going horizontal. We're going left or right. Right? So these transformations work just like every other transformation you've ever seen in Math 1, Math 2, Math 3. It doesn't make a difference. Now we're in college algebra. Still doesn't make a difference. Okay? We are going to go to the left because it's the opposite of the sign. So this says plus, but we're going to go to the left. All right, by pi. So if we look at our intervals down here, pi is 2 intervals from the beginning. Okay? We have 1, 2 intervals. Okay, so what we're going to do is if we're going to go to the left by pi, we're going to go to the left by 2 intervals, 1, 2. So that means we're going to start at negative pi. This is going to be negative pi over 2. We still have to write those intervals down for our period because, well, you have to. Okay, it is part of your grade for graphing, sine and cosine, and the other 4 trig functions we haven't looked at yet. Okay, so now we've done 2 steps. We've done the first step of finding the period and its intervals, and step 2 was address the horizontal shift. Step 3, find the first point. Okay, well, the amplitude says 3, and we're dealing with a sine function. So sine functions begin at 0. Okay, so 3 times 0 is 0. And we're going to start at 0 and negative pi, because that's where our first point is horizontally. So now we've done 3 steps. We've found the period and its intervals. We've addressed the horizontal shift as step 2. Step 3, we found the first point. Since 3 times 0 is 0, that's where we're going to put our dot. Now step 4 is use the amplitude to graph our function. So every interval, we're going to go up by 3 or down by 3 depending on what kind of function we're doing. Because it's a sine graph, we're going to go up 3, then down 3, then down 3, then up 3. This is one period of our graph. And there it is. Nice, gentle, sweeping curves, no pointy pieces. And we're done. That's it. We took those 4 steps. We graphed our function. Okay. Number 2. Okay, again, we're looking at the period. Since the x has neither something multiplied or divided on it, the period's still going to be 2 pi. So I'm going to write down my intervals, 2 pi. Half of that is pi. Half of that is pi over 2. 3 times that is 3 pi over 2. Yep, not over 3. There we go. Okay, so there's our period and intervals, step 1. Step 2, address the horizontal shift. Well, there's nothing on the inside of our parentheses there by the x that is being added or subtracted. Those would indicate a horizontal shift. So we can skip step 2 because there is no horizontal shift. Step 3, find the first point. So now we have to deal with our vertical shift. Okay, so cosine starts at 1, but we got this negative 2 in front of it, and we have plus 2. So negative 2 times 1 is negative 2, plus 2 is equal to 0. So we're going to start our first point at 0 on the y-axis. Okay, so now that we have our first point done, we have to use our amplitude and that negative sign in front of it to help us graph our function. So since it's cosine and it's negative, we would normally go down 2, but because it's negative, we're going to go up 2 more, down 2, and down 2 more. So this is what our graph will look like. There is negative 2 cosine of x plus 2. Okay, let's look at number 3. All right, step 1, deal with our period. Well, now something is being multiplied by x, so we're going to find our new period. So we have 4x is equal to 2 pi. Okay, now we're going to solve for x by dividing both sides by 4, and x will equal 2 pi over 4 is pi over 2, and that's what our period is going to be. So let's put our intervals down here. So we have pi over 2 is our new period. Half of that is pi over 4. Half of pi over 4 is pi over 8. And 3 times pi over 8 is 3 pi over 8. Okay, so those are our intervals for the period. Step 1 is done. Step 2, horizontal shift. Well, we'd had a period change, so I'm not going to give you a horizontal shift at the same time. So there is no horizontal shift, hence you can skip step number 2. Step number 3, find the first point. Okay, so we have this negative 1 for that negative in front of the amplitude. Sine starts at 0. And then this minus 3. This tells us where the first point's going to be. Well, negative 1 times 0 is 0. Minus 3 is negative 3. So our first point's going to start on the y-axis at negative 3. Okay, then our amplitude is 1, but our sine function has a negative and sign in front of it. So instead of going up first, it's going to go down first by 1, then up, then down. And that is the pattern of your sine function, especially when it's negative. Otherwise, it'd be reversed. And there is our function, all graphed. Okay. Problem number 4. Step 1, find the period change. Well, there's nothing being multiplied or divided on the x term. It's being subtracted by 3 pi over 2, but that is not a period change. So the period will not change in this particular function. So we can write our intervals down for a period. So it's still 2 pi. Half of 2 pi is pi. Half of pi is pi over 2. I keep moving the screen. Sorry about that. 3 times pi over 2 is 3 pi over 2. Okay, so step 2, deal with our horizontal shift. Well, this time we do have a horizontal shift. We have this negative 3 pi over 2. That is our horizontal shift. Because it is negative, it's going to go to the right by 3 pi over 2. Now let's look at this, because 3 pi over 2 is from the beginning of our graph, from the y-axis, is 1, 2, 3 intervals. So we have to add 3 intervals to the end of our graph. 1, 2, 3. So now people always get confused about, like, how do I add these numbers if I'm going the opposite, if I keep going with my intervals for the period. Okay, well, you're just going to add some more. So this first one is 1 pi over 2. This is 2 pi over 2. This is 3 pi over 2. 4 pi over 2 gets reduced to 2. Then the next one is 5 pi over 2. 6 pi over 2 is reduced to 3 pi. And 7 pi over 2. You're just adding one more number to the numerator. Okay, so we can erase these. That was our clues. Okay, you can also erase these bottom things on the to figure out how many intervals we moved over. Okay, so intervals have a lot to do with your period intervals that you move over based on your horizontal shift. Okay, so now we have that done. We go to step 3, find the first point. Well, cosine starts at 1. It's multiplied by 2, and there is no vertical shift, so that equals 2. So now we are starting at 3 pi over 2 at 2. Okay, because we moved the whole graph over by 3 pi over 2. So now it's starting at 3 pi over 2 because that was 3 spots or 3 intervals over to the right. Now our amplitude is 2, so we're going to go down by 2 again because it's a cosine, up by 2, and up by 2. We have our graph. And there we go. There's the cosine graph. All right, a couple more examples. We've got 2 more total. So again, step 1, find our period. So our x value is now being divided by 2, so that's a period change. So we're going to put x over 2 equals 2 pi. To get x by itself, we're multiplying by 2. So x will equal 4 pi. So that is our new period. So go down here into the intervals. I have 4 pi. Half of 4 is 2 pi. Half of 2 is 1 pi. And 3 times pi is 3 pi. So our intervals are now done. Step 2, the horizontal shift. Well, there is no horizontal shift. Nothing is being added or subtracted on the inside of the parentheses. So I can skip step 2. Step 3, find the first point. So I have negative 3. Cosine starts at 1 normally, minus 2. So that combined, negative 3 times 1 is negative 3, minus 2 is negative 5. That means I'm going to start my graph at negative 5. 1, 2, 3, 4, 5 at negative 5. Okay, now my amplitude is 3, but it's negative in front of it, so that means I'm going to go up instead of down like I normally would for a cosine graph. And I'm going to use each time, I'm going to go by 3 for the amplitude. So up 3, down 3, down 3. My graph will look like this. And there is my function. Last one. Step 1, period change. Well, nothing's being multiplied or divided to the x term, so the period will not change. So my period is still going to be 2 pi. So let's put that down. We have 2 pi, pi over 2, and 3 pi over 2. Again, 2 pi, half of 2 pi is 1, half of 1 is a half, and 3 times a half is 3 over 2. Okay, so we've done that part. Number 2, horizontal shifts. So we have plus pi over 2, which means we're going to go to the left by pi over 2. Looking at intervals, that is one interval from the y-axis to pi over 2. So we're going to go one interval backwards to negative pi over 2. Okay, so now we have our horizontal position. Excuse me. All right, now for our first point in step 3, we have negative 4 times sine, which starts at 0, plus 3. Negative 4 times 0 is 0, plus 3 is equal to 3. So our graph is going to start at positive 3. Okay, now we use the amplitude to find out where the graph goes. So the amplitude is 4, but it's got a negative sign in front of it, so it means it's reflected. So instead of going up 4 first, we're going to go down 4. Down 4, oops, sorry, my bad. Put my 2 points in the wrong spot. We went to the left. I deeply apologize. There's 3. We're going down 4, up 4, up 4, and down 4. So now we have the points in the right spots. And we can graph it. And there's our sine function. It's upside down because there's a negative in front of the 4. Other than that, the amplitude is 4, so we go up and down by 4 each time from point to point. Okay, so that is the phase shifts. Now we have all the different pieces between period changes and amplitudes and reflections and phase shifts all working together to be able to graph all these types of functions. All right, so it is imperative at this point in time, if you haven't done the practice yet, that you do the practices to get better at these phase shifts and all the other pieces that are involved with graphing these. If you can graph sine and cosine functions with all these shifts and changes, then secant and cosecant is easy, and tangent and cotangent have the same ideas, except the graphs look a little bit different. But we'll get to that next week. All right, please practice this stuff and then come to class with questions.